Hi friends, this is Shekhar Srinivasan for C#.NETprogrammers.com. In this video, I will try to explain a brief introduction about what is .NET framework, what are the enhancements that are being done on .NET framework in various versions, that is what was there in 2.0, what has been updated in .NET Framework 3.x, what is additionally added in 4.x. So let's try to start with the framework. When we say a .NET framework, it is a platform or a collection of many small technologies integrated as a single large technology for developing very powerful application. .NET supports multiple languages and also technologies. It can be considered as a platform where multiple technologies can work together. Now let's try to understand what are all the languages and the technologies that are supported in the .NET. .NET supports various languages like C#. We have a language support for VB.NET. We have a support for VC++.NET. Likewise, we have multiple language support. My .NET supports multiple languages. For every language, the framework provides us some kind of compilers. C# supports a compiler with a name called it as CSC. VB.NET supports a compiler VBC, and for VC++ we have been introduced with a compiler called as CL. In the same manner, every language will be provided with the compilers. Along with the languages and the compilers, my framework also provides something with a name called as Common Language Specification, which is popularly called as CLS. Along with the Common Language Specification, we have been introduced with Common Type System, popularly called as CTS. My .NET framework supports languages, compilers, Common Language Specification, Common Type System. Along with that, it supports two types of specifications like WinForms and ASP.NET. We can develop two types of applications like WinForms and ASP.NET. Along with this, my framework supports a model called as ADO.NET, base class library, which is popularly called as BCL. And one of the major component of our framework will be common language runtime, which is popularly called as CLR. The collection of all this can be considered as a .NET Framework 2.0. This we can consider as .NET Framework 2.0. My framework consists of languages, compilers, common language specification, common type systems, WinForms, ASP.NET, ADO.NET, base class library, and CLR. Now let's try to go in detail for understanding this. Languages are used for developing any type of application. One of the main goals for .NET Framework is to achieve language independency, which means that all the languages are equally powerful. So we can select any language for developing the .NET application. We can select C# or VB.NET and develop a .NET application. Languages are used to develop any type of applications. Once an application is developed, in order to compile the application such that the application can be executed, we depend on the compilers. C# uses a compiler called as CSC. VB.NET uses a compiler called as VBC. Compilers are used to compile the application such that it generates the code which can be executed within the platform. So language and compilers are common everywhere. So to concentrate on the framework, let's try to understand CLS. CLS stands for Common Language Specification. It is a common specification provided by the framework such that language interoperability can be achieved, which means that the code written in one language can be used from the applications developed in other language. In order to achieve that, we need to handle a number of things. So the specification which is required for achieving the language interoperability will be provided by CLS. Any language that targets the .NET should follow this CLS. The advantages: the code written in C# can be used from another application developed by VB.NET. The things which are required for achieving those will be maintained by the CLS. Whereas when I say CTS, it stands for Common Type System. It is a collection of data types that are provided by the framework that can be used. Whenever we try to achieve the language interoperability, one data type will be separate or will be different from the other data type present in other languages. So CTS helps in mapping to that particular data types while working with the interoperability. And when we use our .NET framework, we can develop two types of applications. One is WinForms, the other one is ASP.NET. WinForms is a specification for developing a desktop application or a client server application. Whenever we wanted to develop a desktop application or client server application, we can select WinForms. ASP.NET is a specification for developing web applications or websites and services. Since WinForms and ASP.NET are specifications, they should be implemented with the support of a language. We can use either C# or VB.NET or any language that targets the .NET for implementing these specifications. And ADO.NET, which stands for ActiveX Data Objects for .NET, is a framework or a specification to interact with any database or XML documents from a .NET application developed using any language. With the support of ADO.NET, a desktop application developed with VB.NET or an ASP.NET application developed with C#, if they have a requirement to interact with the database, they can take the support of ADO.NET and it can complete the task. We have been provided with base class library, which is a rich collection of class library definitions that can be used by any language that targets the .NET. We can just assume that base class libraries are somewhat similar to that of the header files of C language. But the difference between header files and the base class libraries are header files of C language can be used only within that language, whereas the class libraries present within the base class library can be used by any language that targets the .NET. If I try to develop an application in C# or VB.NET, and if the application type is same, the same base class libraries can be used. And one of the major resource present within our .NET framework is CLR, which stands for Common Language Runtime. CLR is a collection of resources which are used for executing a .NET application within the .NET environment. CLR takes lots of responsibilities with respect to the execution, the memory management, the interoperability, security, etc. Now let's try to understand the importance of CLR within the framework before we continue further in our .NET framework. To understand the role of CLR, first let's try to understand the differences between a .NET application and the applications developed using previous one. For example, if I assume something called as in C language, say that you are writing a program with a name called as first.c. We try to compile this program with the support of a C language compiler, for example tc first.c. Once I compile this particular program, I get a file with a name called as first.exe. Assume that in our .NET technology, let us say that we are developing a C# application. The extension for a C# program will be first.cs. Okay, the extension for a C# program will be .cs, and assume that the name of the file is first.cs. Let's say that we are trying to compile the C# program. The compiler for the C# program will be CSC, and I just say first.cs. Once I say first.cs, we get a file with the name called as first.exe. Once I compile my .NET application, I get a file with the name called as first.exe. Now, when I just try to observe the C language, here also I have first.exe. In the .NET technology also we have first.exe. When we say the first.exe in C language, it is called as an executable file, which allows the user to execute the file directly. Whereas when I say the first.exe, which is generated from a C# program in .NET technology, will be called with a name called as IL, which stands for intermediate language or assembly. When we try to execute this first.exe, then the instructions will be passed to the CLR, and from the CLR we will get the output. In order to understand the importance of CLR, first we have to have an idea or the difference between an executable file and an assembly. So now let's try to first understand the differences between an executable file and an assembly. When we say an executable file can be executed by the operating system itself. We don't require any kind of additional runtime tools or environment for executing. Now let's say that if I open an executable file, what are the information that consists of? An executable file consists of something called as metadata, an executable file consists of code, an executable file consists of x86 instruction set. So when we try to open an executable file consists of all. Now when I say a metadata of an executable file, the metadata of an executable file provides the complete information about the application, such as the headers that are used within the application. So with the support of metadata, my operating system understands what are all the header files that are used. The code present within the executable file will be in the native format of the operating system, which means that if I write a C program and compile in Windows, after the application is compiled, the instructions will be in the format what Windows can understand. If I write a C program in Linux and if I try to execute it, once the application is compiled, the compiled code will be in the format what Linux can understand. An x86 instruction set provides the complete information which is required for the operating system to execute this file. So if we observe an executable file, this file provides the complete information which is required for the operating system to execute. And hence this file doesn't depend on any kind of additional runtime environment or tools. Now let's try to understand what does our IL, that's intermediate language or assembly, consists of, and let's try to understand why our .NET code depends on CLR for its execution. When we say a .NET assembly or an IL, an assembly can be considered as a basic deployment unit in our .NET, which means that when we wanted to provide something through .NET, that can be provided as an assembly. If I wanted to provide my .NET code such that it can be used in another application, we have to provide as an assembly. We want to allow a .NET application to be executed, even that will be given as an assembly. So we can understand that an assembly is a basic deployment unit in our .NET. Anything you wanted to provide to others from the .NET, it can be possible to provide with the support of an assembly. Now let's try to understand, if I say an assembly, what does it exactly consists of? When we say an assembly consists of something called as metadata. An assembly consists of code. An assembly consists of resource. An assembly consists of manifest. So whenever I say an assembly consists of metadata, code, resource as well as manifest. If the assembly is having an entry point, we call such type of assemblies as an applications that will have exe as an extension. If an assembly is defined without an entry point, then we call them as libraries and they will have .dll as an extension. When I say an assembly is of type class library, or if I say an assembly is of type an application, metadata, code, resource and manifest will be there. If it is an application, additionally my assembly consists of something called as PE wrapper, which stands for portable executable wrapper, which is responsible for invoking the CLR such that the .NET applications can be executed. Now let's try to understand why this assembly is depending on CLR for its execution. When we say an assembly, it consists of metadata, where metadata provides the details about the libraries, the base class libraries that are used within your application. Metadata provides the information, or you can say data about data will be provided by this thing. The code present within the assembly will be in the format of MSIL, which stands for Microsoft intermediate language. This code is in an intermediate format which no operating system can understand, including Windows operating system. It can't understand the code. With the support of metadata, we can get the details about the libraries, the base class libraries used in your application, but the code which is there within the assembly, it is in some kind of intermediate format where no operating system understands. Whereas in an executable file, the code was in the platform dependent format. Whereas here the MSIL code is a platform and machine independent format. And when we say the resource, it provides the details about the external resources used within the application, such as images, icons, cursors, fonts. And if we try to design an application for supporting multiple languages and cultures to achieve globalization, those details it will maintain. Manifest maintains the information about the attributes of your assembly. Now when I try to observe the assembly, it provides the details about itself, but the information which is required for the operating system, that details are not provided. And hence your operating system can't understand how to execute this particular applications. And hence our .NET code is depending on CLR for its execution. So what is CLR means? It is a collection of resources which are used by the .NET framework for executing our .NET application. Now let's try to understand what are the resources present within the CLR. When we say CLR, it's a collection of resources used by the .NET framework for executing our application. For example, to understand the resources, let's say that you have written a .NET program. So we have a .NET source. Say that I'm trying to compile the .NET source. Once I compile the .NET source, I get a file called as an IL, where I said it stands for intermediate language. This can be an application which will have .exe as an extension, or it will have .dll as the extension. Whenever we wanted to execute this, we try to pass this instructions to a person with a name called as CLR, where I said CLR stands for Common Language Runtime. My CLR consists of various resources like base class library support, or you can call it as a class loader, it consists of type definitions, it consists of a resource called as COM marshalling, we have some resource to support the exception handling, something like debug manager, we have something called as exception manager, We have a resource for managing the code, which we call it as code manager. We have a resource called as security engine to manage the security. We have a resource called as thread support for managing the threads. And we have a resource called as garbage collector to manage the memory of the applications. And we have a resource called as IL2 native, popularly called as JIT compilers, stands for just-in-time compilers. So the collection of all these particular resources, we call it as CLR. So once a .NET application is passed to the CLR, then we get the output. So what does CLR means? CLR is a collection of resources used by the .NET framework in order to execute your application. In this video, we just observed a brief introduction about the .NET Framework 2.0. In the second part of the .NET Framework, we will try to understand what are the enhancements that are done on the .NET Framework 3.x and what are the updations that has been done on the .NET Framework 4.x. What are the updations that has been done on the CLR?